All right, so a quick little simplifying review to get us ready for the quiz tomorrow. Let's get right after it. So number one, we need to simplify the square root of 96. So there's a couple different ways to do it. I'm going to approach using the factor tree method. So I'm going to find any two numbers I can that make 96. Nothing jumps out at me, but I know it's an even number. So I'm going to do 2 times, looks like it'd be 48. And then I'll break that down into, I don't know, 6 times 8 maybe. And 6 is 2 times 3. 8 is 2 times 4. And then 4 is 2 times 2. You could break it down any way you want. No matter how you do it, though, you should get to the same set of primes that I have. So now how you count it up are you have your radical. Your pairs go outside and you count them once. So pair of 2's, count it once. Pair of 2's, count it once. Now your loners, I have a single 3 and I have a single 2, go inside. Then everybody gets multiplied. So it looks like this one is going to shake out to be 4 times the square root of 6. And that would be considered simplified. Another way, I don't usually do it this way, but another way is if you can see the perfect squares. You know, perfect squares are numbers like 4, 9, 16, 25, 36, so on and so forth. If you can see these numbers as a factor, it moves a little quicker. So for instance, if you could have realized that this is just the square root of 16 times the square root of 6, well, square root of 16 is a perfect square. It's just 4. So it can be faster if you're good at seeing perfect squares and how they go in there. But I don't do it that way a lot of times. So number 2, square root of 108. I actually know this one is 9 times 12. You could have did 2 and 54, but I'm going to do 9 times 12, which is 3 times 3, which is 3 times 4, which is 2 times 2. So here we go. We count our pairs once. Loners get put underneath the radical. So this one is 6 radical 3. Now, if you want to make sure that you're doing this right, all you have to do is punch your original number into the calculator and then punch this one into the calculator and see if they're the same decimal. So let me show you what I'm talking about. So I'm going to pull up my calculator really quick. And I'm going to move him right over here. And I guess I better shrink this down so that we can actually see it on the screen. There. I think I can get all of it on there right now. Maybe I'll make it a little bit bigger. Not that part. No. Sorry, I'm trying to make this calculator a little bit easier for you to see. But that's good enough. So I'm going to punch in the square root of 108, and I get a decimal, 10.39. And then what did I think? I thought the answer was 6 radical 3. So let's try that one. I'm going to type in 6 times the square root of 3. Enter. And hey, they're both 10.39, so I know I did this problem right. So it might be worth just doing that extra little step to make sure that things are going well for you. Keep on going. Number 3. Well, now we're adding and subtracting. And if you're going to add or subtract radicals, they have to be the same. They have to be like radicals. This problem is set up really nice because they're both radical 3. So pretty much all I have to do is I just have to do whatever the front numbers, the coefficients, tell me. So a negative 2 plus 3, well, that's 1. And then the radical 3 just comes along for the ride. And on a multiple choice test or where you're entering your answer, the 1 is probably going to be left off. And it's just going to be the square root of 3. It's not really wrong the other way. We just don't really write it like that. Well, the next problem is a little bit different because my radicals are different. I have this radical 5 and I have a radical 45, so I can't do any adding yet. Remember, this negative is really like a negative 1. So I have negative 1 square root of 5 plus 3. Well, I'm going to break that radical 45, and I want to try to get this as one of the factors. So I need to figure out what could I multiply that by to get the square root of 45, well, I think it's 9. And why I'm doing this is because the square root of 9 is a perfect square. It's really just 3. So now when I clean this up, I have negative 1 radical 5 plus, well, I have 3 times another 3, so I have 9 radical 5s over here. Negative 1 plus 9, 8 radical 5. And again, I'm not going to go through it all, but I could punch this into my calculator if I wanted to. I could punch it in my calculator, and I could change this to a decimal, and I could enter all that in my calculator. You can do radicals and add and times and all that good stuff, and make sure you end up with a decimal that's equal to each other, and you know you've done it right. All right, number 5, now we're multiplying powers. Remember, when we multiply powers, we add the exponents. So in general, we say that x to the m times x to the n equals x to the m plus n, or you could use whatever letters you want. So looking down here, number-wise, I only have a negative 2. So that's just going to be there. Now when I look at my x's, I have x to the 4th times an x squared. Well, that would be x to the 6th. Now when I do my y's, I have a y to the 3rd, and that's really a y to the 1st. So that would be a y to the 4th power, and I am finished. Number 6 is testing a different rule. It's testing that, hey, can you raise a power to a power? So if we say like x to the m raised to the n, it's just x to the m times n. So now I'm going to multiply the numbers. So writing this out a little bit different, this is v1 u squared raised to the 3rd power. So what I want to do is I want to raise each piece in here separately. So I'm going to go v to the 1st raised to that 3rd power. And then I'm going to do u squared raised to that 3rd power. So notice this 3rd power out here, I raise each piece individually. And now I just multiply exponents. So that's v to the 1 times 3 and u to the 2 times 3. And I'm officially done. If you're totally struggling, another thing you could do with number 6 is you could just do it old school and write it 3 times. So I could write this out. That's the base. I could write out the base, v to the 1st, u squared. And then the 3 just says times it by itself 3 times. And then I could just do it old school, and I don't even have to know this rule. I can just go back to that rule. And I would add them all up, and I get 3 v's, add them up, get u6's, same answer, either way. All right. Number 7, simplify. Your answer should contain only positive exponents, so that means we need to fix negative exponents. So the technical rule is, if you divide powers, if you have like a to the m divided by a to the n, it's just going to be a to the m minus n. I very seldom use that rule though. I typically just try to cancel them out. So for instance, on this first one, the 2 over 3, I can't reduce that. I usually do that first. Well, now when I deal with the a's, this part right here, in my head, here's what I'm picturing. I'm picturing 4 a's on top and 2 a's on bottom. So when they go to battle and they cancel out, I end up with 2 a's on top, which is really the same thing as if you subtract 4, take away 2. And now when I picture the b battle, it's a dead even battle. You know, there's 3 b's. When that war happens, nobody's left. It's all gone. So the final answer here is just 2a squared over 3. Now, negative exponents. The rule to the negative exponent is this. Let's say you have some number, like let's just say 2, and you want to raise it to like the negative 3rd power. Well, technically you're supposed to do 2 things. Number 1, you're supposed to take the reciprocal of the base. All right? Well, this is the base. So the reciprocal of that, the reciprocal of 2 is 1/2. You do the reciprocal of the base, and then you raise it to the positive power. So you do a positive power. And that should fix things. And 1/2 to the third power, well, that's just 1/2 times 1/2 times 1/2, which is 1/8, because you just multiply straight across. Now, another way to kind of think about that works a lot of the time, is you could simply just take this expression, rewrite it with a positive power, and slap a 1 on top. You kind of get the same answer either way, but technically you're doing the reciprocal of the base raised to the positive version of that. All right, well, let's see how that kind of applies with letters here, because there's always easier ways to do stuff. So on this one, I have x to the 4th times, well, y to the negative 3rd is really just the reciprocal of that to the positive 3rd. So that's just x to the 4th times, well, 1 over y times 1 over y times 1 over y is 1 over y to the 3rd power. And the x to the 4th just is on top, and the y to the 3rd is on the bottom. I normally don't go through all that stuff. I typically just look at this and right away say, oh, you got to go down to the bottom, and then I get rid of you and make you positive. So that's kind of how I address it, especially with letters. So let's peek at number 9. So on this one, this is kind of combining rules. So we have some multiplication. We got to raise power to power. So technically, I'm supposed to do the exponents first. So technically, I'm going to do this. I'm going to take this thing and raise it to the 2nd power. So I'm going to multiply -2 times 2. Well, that's x to the negative 4th. And now I have a -2 times a y times an x to the 3rd times an x to the negative 4th. All right, so this part had to be done kind of first before you do everything else. Well, now the -2 is just -2. The y is just y. But now when I look at my exponents, I'm trying to do x to the 3rd times x to the negative 4th. We'll just add them. 3rd plus -4. Well, that's going to be x to the negative 1. So here's what I end up with when I follow my rules. But then I'm like, well, wait a minute. I got to fix that x by throwing it to the bottom. So now just the y's on top. Throw that x to the negative 1 to the bottom. Make it positive. And when you're entering this one in, we normally don't put to the 1st power. So I believe this would just be your answer here, and we would be all set. All right, number 10, it's getting bigger, it's getting funkier. So let's kind of go through. Let's do the top first, and then we'll deal with the bottom. So I'm going to leave the bottom alone. Let's clean up the top. I can't really do anything with that y to the 3rd yet. I'm waiting to do this business, which that business is kind of nasty. So here might be a move where, especially when you have fractions going on, I might view this one and say, you know what? This is just a bunch of crap raised to the negative 3rd power. So why don't I fix that right now by putting that bunch of crap down on the bottom and making it be to the positive 3rd power. So let's go back in and look at what that bunch of crap was. It was a -2y squared. There are other ways to do this, but sometimes I like to kind of fix it right away. Otherwise, you're going to get possibly fractions in there. We could look at it. We'll look at other ways to do it. So let's clean this up. So right now on top, I have y to the 3rd. I have x to the negative 1, but I'm going to fix that. I'm going to put x to the positive 1 up top. So I'm going to kind of fix this person right here. We have a y to the 4th on the bottom, which I know that's going to cancel here in a second. Well, now let's look at these parentheses. I have a -2 to the 3rd power. So -2 times -2 times -2. Well, that's going to be a -8. And then y squared raised to the 3rd, well, that's going to be y to the 6th. So once we kind of go through and we kind of look at all the stuff that we have here, I'll go this direction. We have an x on top. Now on the bottom, we have 4y's plus 6 more y's. We really have y to the 10th on the bottom. And we have y to the 3rd up top. And we still have this negative 8 down there chilling. So now when I cancel out my y's, these 3 are going to cancel out with 3 of those. So I think at the end of the day, we're going to have x over 8y to the 7th. And usually that negative sign, they'll put out front. So you kind of slap it out front that way. And that's kind of how they write it on a multiple choice type test. Which means probably on this last one, I better go back in there, and probably on this last one, you'll also see it, that negative will kind of be out here. It's not wrong the other way. It'll just match up better if you're doing teacher made and trying to get perfect scores on there. All right, these guys should be pretty friendly. These are just our normal algebra stuff. So I'm going to just distribute. That's negative 36. That's a negative 28n. The minus 5 is just at the back side. So now I got to gather up some like terms. We have negative 36, negative 5. That's a negative 41 minus 28n. That would be perfectly acceptable. A lot of times they'll put the variable expression first and the constant second. So either one of these are fine. This is probably be more what you'll see, but who knows? Could be either way. All right, same thing here. I'm going to distribute. Negative 64k, distribute, negative 72. Be really careful here. That's going to be a negative 4k. It's this part right here, because that's a negative 1, remember. That back number is what usually gets screwed up. And a lot of kids accidentally, when they're doing the work, they leave that a minus and just kind of drop the parentheses. Don't do that. The SAT really loves to get you on those. So let's gather up our like terms. We have 64 negative, 4 more negative. That's a negative 68k. Then we have 72 negative, 6 positive. That puts me at what? Negative 66. And I believe that would be our answer for that one. All right, we finish this up with a couple Pythagorean theorem problems where we also have to simplify the radical. So remember, we have leg squared, hypotenuse. So my two legs are 7, so 7 squared. My other leg that makes the right angle is x squared. And then my hypotenuse is by itself. So now we do some math. That's 49 plus x squared equals 121. To solve it, you subtract 49 from both sides. And that's going to be x squared equals 72. And then normally we would just do the square root of both sides. And we would get some decimal. Some decimal, like I know the square root of 64 is 8. I know the square root of 81 is 9. So I know my answer is between 8 and 9. But we want to simplify this radical. So now we're going to do that little factor tree game. So I'm going to break this down. I think of 8 times 9 when I do this one, which is 3 and 3, and 2 and 4, 2 and 2. I know some people that do 8 so much that they basically just go 2, 2, 2, and they kind of know that's what it's going to look like. If you want a shortcut like that, I don't really care. That's fine. But when you do this, you get a pair of 2s, a pair of 3s, and a loner 2 for a grand total of 6 square root of 2. And that should come out to be some decimal between 8 and 9. All right, next one, I got leg, hypotenuse. Let's crank this out. That's 121. 14, I think that's 196. Subtract a $1.21 from both sides. And I get x squared equals, what's that, 75? Square root, square root. Let's break 75 down. Well, how about 3 and 25? And then 5 and 5. So you have a pair, count it once. You have a loner, count it once. And 5 times the square root of 3 would be the answer for this one. All right, hopefully that helps you out, gives you a little bit of a edge when it comes to taking the quiz tomorrow. If you have any questions, ask me in class. See you.